if you want to access the review right now on your either you have a laptop or your phone, you don't need to. I mean, I already have it open right here. Electricity, Nelson 11 material, and then right here, review. Okay, and we're only gonna do these questions. I know there seem to be a lot, but a lot of them are like multiple choice, what you call it, true, false, and basic quick calculation. All right, there we go. Which of the following is a unit for electrical power? Does it matter that it has the word electrical before it? Power is power, right? It doesn't matter if it's electrical, mechanical, thermal, whatever. So what's the answer for that? What's the only unit for power? Power. Power. Light bulbs. How do you measure them? Watts. What do you measure using energy? Sorry, using joules. Joules. Work or energy. Power is for what? Okay. By the way, I didn't teach you kilowatt hour, but actually kilowatt hour also measures energy, and Coulomb measures what? Coulomb. Come on. Charge. Yes. Okay. Next. What are you measuring? What are you measuring when you measure voltage in a circuit using a voltmeter? Do you measure the amount of energy of individual electrons, like every single electron energy? What do you think? Yes or no? Nope. Do you measure the difference in the amount of energy associated with a coulomb of electrons between 2 points in a circuit? Can someone tell me what is a volt? Everyone, what is a volt? Okay, okay, good. Let's review. Okay, everyone. A volt is equal to a joule. Guys, guys, guys. A volt is a joule per coulomb. So how do you relate to that? What do you measure using joules? Energy. What do you measure using coulomb? Charge. So it's B. A volt is the difference in the amount of energy associated with a coulomb of charge, because remember, it's 1 to 1 to 1. It's 1 to 1 to 1. So whenever you measure voltage, you are measuring the amount of energy with moving how many coulombs? 1. Because if you change this to 10, what do you change this one to? 10. So you're always measuring energy per a single coulomb. Okay. There we go. Okay. 6. Number 6. Come on. What device is used to measure the electric potential difference in a circuit? Yes. Voltmeter. Ammeter measures amperage. Ammeter measures amperage. Ohmmeter measures what? Ohms, which is resistance. Voltmeter measures what? Voltage, which is another word for potential. Potential meter, there's no such thing. It's basically voltmeter. Voltmeter. Actually, some people like to call it in England. I think they call it potentiometer. Potentiometer. We just call it voltmeter. Okay. All right. So it is the voltmeter. Number 7. When an electric current is actually present in a circuit, which particles only move? Which particles are only allowed to move in a circuit anyway? Electrons. Protons and neutrons are bound to the nucleus. Electrons are freed up and then what? Move. So it's electrons. Number 8. What electrical component does this represent? This is also what? A resistor. So it's not a connecting wire. This part is the connecting wire, everyone. This part is the connecting wire. Battery, what's the symbol for a battery? Or any voltage source? The long line next to the short line. Long line is always the what? Positive terminal, which means short line is the minus. Nice. Lamp. By the way, here's how we represent lamps. Everyone look. Lamp, lamp, lamp. Where are the lamps? Ah, there. No, that's still a lamp. Oh, we'll get to see what a lamp looks like. Resistor, yes. Okay, next. 8, 9. Which equation is equivalent to resistance? First of all, what's V times I or I times V? It's the last thing we studied yesterday, which we barely used. Power. P is equal to IV. So that's not it. This is power. Is this resistance? This is I over V. I over V. Is that correct? What is the resistance? It's not I over V. It's what? V over I. So it's this guy. V over I. What's the fourth choice? Is that even correct for anything? No. 1 over IV is absolutely nothing. Okay. Next. Is this statement true or false? Electric potential is a measure of how much electric potential energy is associated with each charge. Each charge. Why is it false? So how would you correct this statement? First of all, okay, wait a minute. Is electric potential a measure of energy anyway? Yes, but is it with each charge or what? It's in a circuit with a moving charge. With a moving charge. So with the whole charge just going. So this is a false statement, and the only falsehood in it is this word, each charge. You should say with the whole charge moving, with the total charge moving. The vector, remember, but see, everyone, voltage, delta V equals energy, delta energy or work, divided by Q test. So a voltage is equal to energy, joules, over what? Over Coulomb. That's why. So again, volts is not energy, but it's related to energy. Volts is related to energy, but it's not energy itself. Say again? Because, yeah, the statement said that, yes. You still have to say associated with moving a charge. That's the thing. Between 2 points is how much energy it took you to move a 1 Coulomb from here to here. That's the definition. Okay? All right, next. Conventional current is going from negative to positive. Conventional. Conventional. It's positive too. So what do you call the one that actually goes from negative to positive? What I call it physical, because it is the actual physical motion of electrons. Okay, so this is a false statement. Direct current is the flow of electrons in back and forth. When you actually when we actually used a battery, was the current going back and forth in the circuit or just in one circular direction? Which means, is direct current back and forth? What is back and forth? What's the opposite of DC? AC. Instead of direct current, alternating. Alternating means up and down, up and down, up and down, which is basically how power grids work. Okay, so that is a false statement. The symbol I is used to represent electric current. Is that correct? So, okay, how many people say this is correct? Yes. I represents current, V represents voltage, R represents resistance, and that's it. Okay. 17. Oh, sorry. 17. Superconductors are materials with almost infinite resistance. When you conduct very well, do you have a big resistance or a small resistance? Which means superconductors have a what? Have an almost infinite electrical resistance or an almost zero electrical resistance. Almost zero, exactly. So that is a false statement. Is this equation correct? Sorry. Is this equation correct? What's incorrect about the whole statement? For resistors in what? In series. What's the equation for in series? You just add them up. Well, this is the equation for what? For parallel. Okay, 1 over R parallel is the flip of the addition. Flip of the addition. Okay. 25. Okay, go ahead. Calculate the amount of power required to charge a battery of 1200 joules of energy transferred in 5 minutes. Okay, Calculate power. And what information are you given? Come on. What information? Munir, guys, come on. Munir. You are given energy, and you're given what? Time. Do you need anything from this unit or 2 units ago? 2 units ago. All right, so let's do this. So the equation is P, sorry, P equals what? All right. How much energy are we talking about? How much? 1200? How much time? But it has to be 5 seconds. What's 1200 divided by 300 exactly? Yep. You can always cancel the zeros together. Oops, sorry. And you would get 4. 4 what? 4 watts. It's a power. 4 watts. Okay. All right. Say again. Oh, did it say kilowatts? No. Are you? Oh, you look at this one. No, everyone, we're doing this one. This one. Okay. All right. 27. Calculate the electrical power difference between the negative and positive terminal if 1080 joules is needed for what? 120 coulombs of charge. What equation do I use now? Calculate the electric potential difference, so delta V. What's the equation for delta V? Come on. I wrote it a few minutes ago. That's it. Okay, you're right. V equals IR. Do I have any current or resistance information here? So Ohm's law is useless here. So what's another equation? The only other equation with delta V in it. Say again. Delta E over Q test. Oh my God, guys. You see, when that happens, I get in trouble. Not you. It's like, oh, you can. Delta E. 1080. 120. What is that? Nine what? Unit. Volt. Delta V equals delta E over Q charge or Q test. Yes. I'm sorry? Yeah, and this is voltage as well. Oh, okay. This one is when we use Ohm's law. This one is when I tell you that the energy difference between 2 points on the circuit. Yeah, yeah. Okay. All right. 28. Okay. Potential difference across the terminals of a light bulb is how much? If the light bulb transforms or uses up 480 joules, how much total charge has passed through? Is it the same equation still? Yes, just a different algebra. So delta E, sorry, Q test equals what? Delta E over delta V. How much energy are we talking about? 480 And how much voltage? 120. How much is that? For what? 4 coulombs. So 4 coulombs of charge have passed through if 480 joules of energy were needed with 120 volts of voltage difference. Okay? 29. Okay. A 35-watt light bulb is on for how much? How much time? 2.5 hours. If the potential difference is 120, how much charge has passed through? Okay. We have 3 numbers, not just 2. We have power, we have time, and we have charge. Sorry, voltage. We're looking for charge. What should I do first? But which equation? I can't use it because there's no resistance. Remember, everyone, you can only use that equation, I equals V over R, if there is resistance information. Otherwise, it's useless. Layla, what equation do I start with first? Okay, everyone, I'm hearing way too much chatter. Way too much. Okay. Can we use this equation right now? I don't think so. We have delta V. We have, but we don't have what? Do we have delta E? No, we don't. Okay. What other equations have power and delta E in them? Exactly. So the first thing is delta E equals P delta T, which is how much? What was the power? The power was 35. I need to convert to what? Convert to what? Seconds. Okay. 35 times 2.5 times 3600. All right. Let's see how many joules we're talking about. 35 times 2.5 times. Oops, sorry. And now what do I do? Now what do I do? Sure. Yes, you're right. Look, everyone. Oops, sorry. Now I can use this one, right? So delta V. Sorry. Do we have the voltage? Yes, we do. So 120 equals 315,000 over Q test. Layla, how would you solve this? Cross multiply. Yes. Q test. Two six two five. What's the unit for this number? Coulombs, because it's a charge. So everyone, you see that in this unit, you might actually have to go back a lot to use what? The power equation from the energy and work unit. Okay, happens a lot. Yes. Oh, because it's given to me in hours. I can't. What's the unit for time? Standard. Second. That's why. Oh, but why 3600? 60 times 60. An hour has 60 minutes. A minute has 60 seconds. So you can either multiply by two 60s in succession, or just one shot, 3600. 1 hour has 3600 seconds. Okay. 30. Okay, everyone. We have a circuit. What's this symbol for? What's this symbol for? This is a battery, a voltage source. What's this one? What's this one? Resistor. Okay, so we have resistor 1, resistor 2, resistor 3. All right. What's up? Redraw it to tell me where you would place an ammeter to measure I3. Question. What does an ammeter do? Does it use two hooks, or does it just go in? An ammeter. It goes in. So, everyone, yes, sure. So, it would look like this. Look, everyone. Let me show you. Sorry. Oh, are you kidding me? Yeah, okay. Sorry, everyone. 1 second. 1 second. Okay, I'll sketch it real quick. Which current are we trying to measure? Through 1, through 2, or through 3? 3. Everyone, this is how you symbolize. This is how you would symbolize how you actually put an ammeter in. You just cut through, like we did yesterday on the website with the big resistors, and you just sketch a circle. Sorry, a circle. Do you put A or V inside the circle? A. A for ammeter, V for voltmeter. Thank you. Yes. As long as everyone, look, Layla has an amazing remark here. As long as you put it anywhere along this whole path, you are going to measure the exact same density of electrons because they have not split yet. Is it making sense? You always have to put it within the single path in which that resistor is placed. That's it. Perfect. Yes. So we can put it here, everyone. I can put it here. I can put it here like I already did. I can put it immediately after it. I can put it right before it combines again with the junction. As long as it's in this arm exactly, I am good. Okay. What else do they want us to do? Oh, a voltmeter to measure what? To measure what? To measure which voltage? V2. Now, how does a voltmeter put itself through the circuit? Does it go in or steal two hooks? So that means, how would you actually do it? Well, let me just how would you put it here? Is this correct, everyone? Is this correct? Is this correct? No, because that's how you place a what? An ammeter. How do you place a voltmeter? Remember yesterday when we did on the, like when Tariq and Nadim held them and I used my fingers as hooks. Where did I? Two touching points. Exactly. So that means what? Uh, undo, undo. Asser, where would you hook it? Exactly. Before it and after it. Right there. So right here and right here. And what do you put inside the circle? FV. This is how you always connect a what? A voltmeter. Two hooks wherever you want to measure the difference in voltage points. Always like this. Okay? Don't worry about an ohmmeter because I'm only gonna give you questions about what? About voltmeters and ammeters. Okay. 31 is it? 32. What's wrong here? Connecting an ammeter like a what? By the way, just so you know, everyone listen up. Everyone, if you connect an ammeter like that, it will blow up. If you connect an ammeter like that, it will blow up. And the reason is ammeters come with very small resistance. So let's think about this. Everyone, this ammeter has very small resistance, which means it introduces a path of least resistance, right? Path of least resistance. What? Oh, like the path of the lowest resistance. So what are the electrons going to do? Are the electrons going to like to go through this path or through this path? The ammeter path, right? So are you going to have a small current through the ammeter or a huge current through the ammeter? What happens to a circuit that has an overload of current? Exactly. Yes. Never connect an ammeter in what? In parallel like this. Never, because it will steal most of the current. And the circuit is not ready to do that. An ammeter butts right in. It shoves itself inside of the circuit. A voltmeter does what? It steals this. It steals the what? It steals the current. Exactly. A voltmeter has, because if a voltmeter has a low resistance, it will what? It will steal most of it. No, it wants it to almost halt most of it and just to have it gone through the what? The original path. Yes, always remember, ammeters have low resistance. Voltmeters have what? Uh, in a way, yes. Basically, the resistor inside of it is very high. The resistor is probably in the yellow range or the, yeah, I think yellow or purple. Actually, why am I guessing? Yep, into the blue or purple or even gray range. Not again, depending on how much it's able to what it's able to handle. But in general, never connect an ammeter in parallel because it will steal all the current and it will fry. Okay, good. Next. Oh, sorry. Um, okay, yep. Calculations. Come on, come on. You do this. Calculate the amount of current. So I in a wire, if 0.75 coulombs pass through in 1.7 minutes. Which equation? Half the battle is knowing which equation on the formula sheet to use. Well, ask yourself first, what givens do you have? What are you given? You're given what? You're given I. You're given. Sorry, you're given. Sorry, what did you say? Time. You're given time. So we have delta t. Good. What else? We're given charge. What equation combine charge and time? What equation or equations? Come on, combine charge and time. Only one. Something over time. It's charge. It's this one. Charge over time. Charge over time. So I equals Q over what? Delta T. How much charge are we talking about? 0.75. How much time? 1.7 minutes. So got multiplied by 60. Yep, you got it. 1.7 times 60. So 0.75. 1.7 times 351. So 1 point 1.7 times 351. 1.2. Sorry, 120. No, not 120. My bad. 110. 110. Why am I fighting this? 102. Sorry. 102. All right. Divide. You get almost 0.74. Yeah, 74. 0.0074. In what unit? Unit. Amps. Because the I is the amperage. Yes, absolutely. It's the current. Current. current or amperage. Either way you say it, I'm okay with that. Okay, next. How many coulombs pass through a wire that carries a current for 3.2 amps for 5 hours? Same equation? 100%. You just have to crisscross. All right. So Q equals I delta T. Bless you. What's the current? 3.2 amps. What's the time? 5 times 300, 3,600. All right. In coulombs. How come this is a big number? We said the numbers for coulombs are usually small, in the nano or the micro or the milli or even the single coulomb. Why is this a big amount of charge? We let the current go for 5 hours. Of course, you expect a huge amount of charge to pass through. Okay. 33, 34, 35. Okay, time. Can I still use the same equation? Yes or no? What I have? I have 3 coulombs and I have milliamperes. Can I use the same equation? Yes, same thing. Three coulombs. How much? I. -3. 750 times 10 to the -3. Okay. Use the 3 divided by 750 exponent 3 minus 4 exactly. For what? For 4 seconds. So it took 4 seconds. Nadim, you have 2 equal signs. The middle equal sign should be the arrow. Yes, 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 yes. Okay. Your words. 36, 37. Okay, you do this. On your board, sketch and then raise it and show me if your answer is correct. Come on. Draw a circuit with a battery and what? 2 lamps or 2 resistors in what? Go ahead. Come on. منير صباح الخير. هذا راحتك يا حج. As you wish. هذا راحتك. Sorry? Oh, forget. No, that's what. Forget the lamp. 2 resistors. A lamp is a resistor, by the way. A lamp. Okay, when you touch a lamp, the old lamps, do you feel it cold or hot? So it's heating up. That's what a resistor does. So just sketch 2 resistors. So, second. Okay. Hold them up. Hold them up. One more minute. Okay. Correct. Mo, correct. Yes. Parallel. 36, number 36. Draw a circuit with a battery and 2 resistors in parallel. Haley, show me. Okay. To what? Oh, sure, yeah. What? Okay. Is the current splitting between them? Not the way you did it. Yes. Uh-huh. It has to split. The first time you did it was what? Was going through one single shot. Sorry, say again, Leila. Yes. Oh, everyone, my bad. This was incorrect. See, I made a mistake. I made a mistake with my mental cross multiplication. It should be what? It should be, yes, I is the big thing. It should always be on top. Yes, sorry. So that should be, you're right. You're right. You're right all the way. I completely butchered this question. Oh, oh, it is the same thing. Oh, but I wrote the first equation incorrectly. Okay, so it is still 4 seconds. Wow, I am out. By the way, I only slept for 2 hours last night. No, no. If you actually, everyone, if you actually check when I posted the videos, 3:30 a.m. Yeah. So I'm running on very, very like I'm 2 sandwiches short of a picnic, as they say. What? My battery is completely depleted. Okay, so let's sketch that question, the circuit. How many people did this? For that? Yes, because it has to split. Okay, this one. Forget the lamp. So sorry. Instead of a lamp, just make it a resistor. So draw a circuit with a battery and a resistor that's in series with two resistors that's in parallel, that are in parallel. Come on. So you need three resistors, one in series with two that are in parallel. Doesn't matter. Taking like sketching circuits is your first time ever sketching circuits, so it takes time to master the art. So instead of a lamp, just make it another resistor. DC. Second. Oh, that's the resistance. The zigzag line. Anyone else? Because it goes first through and then it splits. Yes. One resistor in series with a parallel combination. Ali, what'd you get? Yes. Hold it up. Any variation of this is fine. Exactly. As long as you have one connected to a group, you're fine. Perfect. Good. All right. Next. 38. Oh, everyone, here it is. Here's a lamp. Let me just zoom in. Here's a lamp. Does anyone know why a lamp looks like this? Because the old lamps, the one invented by Thomas Edison, the old filament ones, used to look like this. Everyone, used to look like this. The filament that heated up and actually produced light was actually this part right here. Looks like the flower diagrams you see in biology. So that's why it looks like this. Yes. Oh, by the way, okay. Think about it. Anything could be a resistor, right? Because everything. However, lamps, whenever you hear lamp or load, you know there's a resistance associated with it because it heats up. Mhm. Yep. Yep. Exactly. Yep. That's it. Okay. What's the question here? Actually, let me jump to the ones where with circuits. 40, 41, 42. Okay, this one. Calculate the resistance. What's the only equation we have for resistance? When it's combined in a circuit, there you go. I equals V over R, or V equals IR. So we have a voltage of 60 V and a current of 750 milliamps. All right? So we'll do this. R equals V over I, which is what? 60 divided by 750 times 10 to the negative 3. Yep. Okay, who's got this calculation? 60 divided by 750 milliamps. So you use the X button. You've got a resistance of how much? 80 what? No, resistance. Remember, when you say volt, it's like you're saying voltage. So that's not it. Resistance is ohms, the Greek letter ohm, this guy. Okay, all right. This one, an 80 ohm carries 0.85 milliamps. What is the voltage difference across that single resistor? What equation? V equals IR, exactly. It's just a multiplication now. So that's it. What would that be? What's the unit? What's the unit? V, V. Okay, look at this one. Come on. 42. We have a circuit. How many batteries do we have? One. By the way, could you make a circuit with multiple batteries? Oh, all the time. By the way, the ones you see in first year physics could have like 3 loops, and each loop has a battery or 2, and you have to see how it loops inside and the whole thing. But I'm only gonna give you what? One single battery. How many resistors do we have? 2. And both of those are connected in series, in a single chain or train. Okay. Yes. Oh, then you know for a fact that at least one battery is going to be getting charged up. Do you see what I mean? Basically, it becomes a tug of war between all of them. You know that at least one of them is going to be charging, and one of them is going to be what? One of them is going to be discharging, like actually acting as a real battery, expending energy to get everything through. And the other ones are not going to have enough power to what? To drive their own current. So they're going to what? Send or receive current? Receive, because a battery sends current. But if it's not strong enough, it's going to what? The current inside going into it is going to be bigger than the one that could actually what? And it actually becomes a chargeable battery. Yep. Say again? What do you mean the circuit doesn't go around? Yes. Yeah, but a battery itself is still a path. Remember the electrode, the terminal, and the positive. They still pass through it. Nothing. The difference is that instead of this battery being able to drive them from its positive terminal to its negative terminal, right, like a conventional, it's going to actually have them go the other way around. Does anyone know? Listen up. Does anyone know what a valve is? How many people did know about the heart valve? What are the heart valves? They only make blood go in what? One single way. You don't want the blood to be like certain valves are basically open this way, so it only could latch this way. And if blood trying to go this way, it actually it's blocked most of it. So think of it. A battery also has a valve. If the valve is strong enough, it allows it from what? From positive to negative, right? Because that's the conventional natural current, right? But if the valve is overpowered, what's going to happen? It's actually going to go in the other direction. But only if you have an overpowering battery on the other side able to what? It's in general, it's not just the actual strength of the battery, it's where it's placed as well. You see what I mean? Because depending on your battery power and your resistor combination, you might send a lot of current or a low current. That's why. Somewhat like this. Yes, it's a bit more complicated, but it still has to do with the entire combination as well. Okay. Okay, let's come back to this. Yes. Compared to the not just that. In which loop? Is it on the upper loop, bottom loop, in the middle, junction, all of that? It makes. Oh, because it matters. Okay, because when you place it in a different junction, it's gonna split differently. Okay, so think about it this way: if you place it on the bottom junction, it's gonna actually be more dominating in the lower loop. But if you place it in the upper junction with another battery down there, that means what? Now you have a different dominating one in the bottom loop. So it's just. I will show you examples of first-year physics problems. I have them on my hard drive right here, and I will show you exactly how they look like. Okay. Okay. This circuit has a current of what? How much? Half a milliamp. Question to you: is there multiple currents or one single current in this circuit? No. But look at how it is. Is there any splitting points? Exact. So the whole time, everyone, the whole time, how much is circling around? 0.5 milliamps through the battery, through this resistor, through this resistor. Okay. How much is V1 or the V across the what? The first resistor. How much is V1? 4.55 volts. And the potential difference across the what? Is how much? Okay, pencils down. Pencils down. One question about yesterday. Everyone, one question about yesterday. Does anyone remember the last step we did? The last step we did to check our answers for the big circuit at the end of the day. What did we add? Did we add the currents? No, we add the currents only when we split and come back, just to check the loop. I added the what? The voltage of group 1, the voltage of group 2, the voltage of group 3, the voltage of group what? 4. What did we get when we added them within rounding error? We get 120.1, which is very close to what? What does that mean? 120 given by the battery is split over what? Everything. Do you see what I mean? Everything somehow has to add up to what? Or basically the what? The battery. Okay. What's the strength of the battery? 12. How much is this stealing? How many resistors do you have remaining? What's the only possibility for the voltage across that resistor? What do you do with those two numbers? Add or subtract? Think of conservation of what? Conservation of energy. Okay. So 12 minus 4.55 is what? 7.45. So right there, everyone, V2, everyone, V2 equals what? Umayma? 7.45. Okay. So now, what do we know? Can someone tell me what numbers do we know about resistor 1? What numbers do you know about resistor 1? Do you know the voltage? Yes, we do. Do you know the amperage? Yes, we do. Can you calculate the resistance? Good. Let's talk about resistance 2. Do I know the voltage? I just calculated 7.45. Do I know the amperage? Yes, it's the same one because there is no splitting. Can I know the resistance? Done. That's it. The tracing method is one of the best ways to really understand what's going on. So that's basically how we do this question. Okay, so can someone tell us what they are? Okay, come on, do this calculation quick. So apparently we got 7.45 for V2. Can someone tell me what's R1? Oh, okay, everyone, question. What if I ask you right now, without finding R1 and R2, find me the overall resistance of the whole circuit? V section equals I section times R section, right? So V circuit equals I circuit times R circuit. What's the V of the whole circuit? 12. What's the I in the whole circuit? 0.5 milliamps. Can you right now calculate the resistance of the entire circuit? Yes, V over I. That will not give you R1 or R2. That will give you the what? The what? The combination of both of them. Again, you can look at it in so many ways. So who's got R1? Basically, I want you to divide 4.55 by half a milliamp, which should be a big number. By the way, just so you know, my questions, usually my questions, I will give you low resistances, like the one I gave you yesterday, 60 ohms, 70 ohms, 10 ohms. But actually, most of the time, your ohmage is what? High. You're usually in the kilos, megas. I barely in the gigas, but usually kilo and mega. Yes. What do you think? By milliamps. Sorry. What does matter? You have to. You have to. All of these equations are physics equations. So what's the answer? 9.1. Is it 9.1 kilo ohms? I think it is. It is 9.1 kilo ohms. R1 is 9.1 kilo ohms, or 9,100. Okay, what's R2? Come on. What's R2? 7.45, the remainder voltage, divided by the same thing, which will be 14.9. Yes, 14.9 kilo ohms. Yes, milliamp. Yeah, I did it in my head. You have to. Yes, you have to. A physics equation needs to be standardized in and standardized out. Okay? Yes. Otherwise, you're going to get an answer 1,000 times smaller or 1,000 times bigger. But you got to be off by a factor of 1,000. Okay. Good question. All right. This was 42. What's the next one? 45. Everyone, 45. Okay. Is that the one you just sketched? That is the one you just sketched. Okay. Calculate the total resistance in the circuit. R1 is 6.1. R2 is 13. R3 is 27.2. Go. Question. Are they all connected in series? Are they all connected in parallel? Are they mixed? Which one do you start with? You always have to start with the what? With the parallel group. Go. You have to do the 1 over REQ. Come on, come on. 1 over 13 plus 1 over 27.2. Just plug it into your machine and get decimals. It's okay. Hey, come on. Don't forget to flip. Don't forget to flip. Let's keep it to 3. Let's keep it to 3 in the final answer. So okay, sorry, yeah, you're right. This everyone, this one right here is 13, and this one is 27.2, and this one standalone by itself is 6.1. So 13 and 27.2. So everyone, this is how. So okay, let me check. Everyone, bracket 1 divided by, sorry, bracket, come on, bracket 1 divided by what is it? 13 plus bracket 1 divided by 27.2. Okay, what do I do with this number? Flip it. That's it. 8.796 is this combination squished together. What do I do with that number then? By the way, this number represents those two things. Look, those two things compressed to one. Compressed to one. So something right here. Something right here. Then what do I do with that and the R1? Because they're now connected in what? Everyone, look. Do you actually see how it actually does look like it's connected in series? Because I took them, replaced them with just one. That blue one right there, that thin line. So I add what to 8.79 for 6.1. This is 6.1, and those two have been squished to what? Squished to 8.79. So plus 6 point. So the entire resistance of this circuit is how much? 14.89, or to 3 figs, 14.9 ohms. Okay, that's it. All right. Okay. $46. Okay, this is yours. Go. How many resistors do we have? They're connected in what only? Great, that's an easy one. How powerful is my battery? 8. Let's just okay. Wait. 1 minute. Let's just do it mentally, and then we're going break. What's the strength of the battery? 18 volts. How much is measured across V1? V1, 7. Right there. How much is left for V2? 11. So 7 and 11 add up to 18. Okay. How big is R2? How big is R2? 30 ohms. I know V2 and I know R2. What can I calculate? Amperage 2 or I2. How do you do that? Nope. Divide what? The voltage by the resistance. So you divide 11 by what? By 30. Okay. How about R1? What do I know through R1 or across R1? Exactly. I know the amperage of V1. Sorry, I know the voltage of V1, which is 7. And I just found out the what? The amperage through the whole thing. So now I'm going to divide what? V1 divided by the new amperage to give me the what? How big R1 is. Okay. Is this circuit as simple as the one we just did? No, it's not. That's fine. So we have a circuit. How big is the, sorry, how strong is the battery? How strong is the battery? 22 volts. Okay. Which means what? Listen up, ladies. Which means what? When I add all the voltages for this one and this whole group, I should get how much? I should get 22, no more, no less, within rounding error. Okay. What do we know about this? We know that R1 is how much? 3. R2 is 6. So 60. We know that. Okay. Listen up. How big is this? 22. The difference across the battery is 22. V1 is 12. So how much is left for the entire, guys? How much is left for the entire group? 10. Because remember, 12 here, 10 here gives you what? Do you remember the good news about things connected in a stack? What's the same across all of them? If they're connected in parallel, what is the same in this one, in this one, in this one, in this one, all of them? The amperage or the voltage? The voltage only. The voltage only. Which means what? If it's 10 here, it's also what? 10 here. And it's also what? Nice. Okay. Okay, everyone. Let me actually do this real quick for you. So just give me a second to snip and this. I don't need. Give me 1 second to just copy this. All right. Okay, come on. Come on. So let's put some numbers. How much is here? Eyes up. 22 volts. How much is here? 10, no, 12 volts. Okay. How much is R1? 3 ohms. How much is R2? 60. Okay. If this is 12 and this is 22, how much is left from here to here? Which is also going to be from here to here, and also what? From here to what? All right. So let's actually put 3 tens here, or 2 tens only. All right. 10 volts. 10 volts. All right. What can I calculate now? I'll give you a hint. The top resistor, I know its voltage and I know its resistance. I know the voltage of R2 and I know the resistance of R2. What can I calculate through R2? I can calculate the what? The amperage or the current or the flow of electrons. All right, let's do that right here. I2 equals 10 divided by 60, which is how much? 1/6. That's 0.167 amps. Great. Okay, what else? What can I know about resistor 1? I know the voltage, I know the resistance. What can I calculate again? The I, which is interesting. This I, everyone, the I through R1 is the what? Is the smallest or the biggest I possible? Why? Because it's the one coming straight out of the battery. Perfect. So everyone, I1 equals 12 divided by what? 3, which is how much? 4 full amps. Wow. How can you know? Listen up. How can you know the amperage in this arm? I'll give you a hint. You have the water hose. Everyone, look at my hand, and then it splits. How much is in here? How much is here? 4. How much split up? Up. 0.167. How would I know how much is here? Exactly. 4 coming in. Only 0.167 went up, which means how much is going to go down? This, exactly, this minus that. So I2, because I divided the voltage of 10 divided by the ohmage of 60. That's yes, yes they are. Well, I'm sorry, no, 60 is given. Ali, tell me how we found out that this is 10 volts. The whole battery is 22. 10 for the combination, which means 10 for every part of that combination. Yep. So I3 is equal to what? 4 minus 0.167. How much is that? That's 3.8. 8, and 6, 7 is 33. Check. 4, subtract 0.167. Yep, 38833. Okay. How can I now calculate R3? R3. What do I know about R3? I know the ampere, just found it, and the voltage. All right. So R3 equals V3 over I3. 10 divided by 3, 833. 2.60. Question: does it make sense for that bottom one to be such a low ohmage? Yeah, because it's stealing most of the current. Remember, when you steal a lot of current, you are superconducting. You're letting everything through because of the path of least resistance. Yes, path of least resistance means path of most traveling. R2 was 60. 2.6. Yeah, we just got 2.6. So low, which is why is exactly it's stealing like 90% of the what of the amperage. Is it making sense now? That's the only way it could happen. Oh no, like this one is stealing only 0.167 amps. This one is stealing 3.83 amps. Has to be right because the water hose cannot leak or gain from outside. All right, next. 40 53. Okay, come on. Easy one. Why is it easy? Because it's purely in what? In series. Why didn't you just come up with your own? Seriously, come up with your own. No, like as a practice. You come up with your own, you design it, you give it. It's like when you teach yourself factoring. And how many people did this when they were studying factoring? Um, your friend expands and has the answer, and then he gives you the final answer, and you have to work it backward. They already have the answer because they are the ones created it. So you can just come up with your own circuit. By the way, okay, but to Layla's point, I will post some review questions, and then I'll give you a couple of days to work on it through next week, and then I'll post the answer. Okay? All right. What's the deal here? What's the voltage of the source? Source 20. Okay. How many resistors do I have? Somehow the voltage in both of them must add up to 20. All right. R1 is 30, R2 is 12. In 10 seconds, how many coulombs of charge pass through the circuit? Wow, this doesn't seem even like a circuit problem. Like, where's the R1, V1, that kind of stuff. Okay, what do you think I should do first? I need the number of electrons. Sorry, the amount of coulombs. Well, that's the second step. What's the first step? Whenever you see a circuit, what equation do you always need to use? I equals what? V over, or V equals IR. Okay, question everyone. Can I get the current through the whole circuit? Well, I can't get it until I get the resistance of the whole circuit. All right, so let's do another. Everyone, here's another snip. And sketch. Okay. 1 second. All right. Okay. What's Req? Req. What is it? Only two in series. What do I just do? Add them up. So this one is 30, and this one is 12. So 30 plus 12 is equal to how much? 42. Okay. So what do I do now? I circuit equals V circuit divided by R circuit. So everyone, I circuit. Sorry, I battery. Let's call it I battery. I don't care if you call it I circuit. I battery equals 22. Was it 20 or 22? 20. 20. Yes, 20. 20 divided by what? 42, which is slightly less than half. How much? 0.476. So 48. Okay, I got the amperage. What do I do with that? If I want charge and I have time, I equals Q over delta T, or Q equals I times delta T. So I'm going to do it in a different color. Q equals I delta T. Yeah, go ahead. That's for this driving source, which means it's basically going to be both of these V1 and V2. Yes. What is that? How much is this? What's the unit? What's the unit? Coulombs. Thank you. Okay. All right. Next question. What's the next question? 54. Oh, 54 is up. Okay, come on. That's yours. V source is only 5. R1 is 7. V2 is 355. No, not R2. Nope. Yes. How big is the whole V? 5. How much is V2 stealing? So how much is V1 left to steal? 5 minus 3.55, which is 1.45 volts. Great. So what do I know? What do I know about this one? I know the R2, and I just found the V2. So what can I calculate from both of these being divided? The amperage. And because the whole thing is in series, that amperage you found is the what? Is the same for this one and the same that's coming out of the battery. Good. So how are you gonna find R? Okay, so R2. Yes. So you can find R1. Okay, you know what? Let's do it. Yes. 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 Okay, let's do this. Come on. Okay, V1 is 5. V1 is 5. V2 is 355. R1 is 7. Okay, so V1 is 1.45. So I know R1, I know V1, so I can get what? I can get the amperage. So I is equal to 1.45 divided by 7. How much is that? How much? 0.21, which means 0.21 here and also what? 0.21 here. Yep. So how can I find R2 now? Divide voltage by the amperage you just got. All right. You get about 18. You get about 18. 16.9. In what unit? Ohms. How strong the resistor is. Yes. High numbers, high resistance. Okay. Haley, can you tell me how we're going to do part B? How long will it take 12 coulombs of full charge to pass through this circuit? Exactly. So I need to use Q equals I delta T. So I'll do it a different color. Delta T equals Q over I, which is what? Which is 12 coulombs divided by 0.21. That's going to be roughly 50 something. 50? 57, I'll take that. There we go. Okay, next one. 55. 55. How much is the source? Come on. How much is the source? How much? 12. Um, R1 is 5, R2 is 16, R3 is 30. Do I have any information about the resistors other than the resistance? Nope. I don't know the voltages across each one, and I don't know the amperage through each one. But do I know the resistors, all of them? Can, can I calculate the full resistance of the circuit? Yes, we can. All right, let's do this. Go ahead, you can start. All right. Okay, so how would we do this? First of all, which two resistors do we do? R1, R2, R1, R3, or R2, R3? Yes, so 1 over Req equals 1 over, what's R2? R2 is 16, and this one is 30. All right, so 1 over 16 plus 1 over 30. A common denominator is 480, which means it's got to be 30 plus 16, which means Req, when flipped, is going to be 480 over 46. How much is that? 480 divided by 46. Whoa, made a mistake. 480 divided by 46. 10.4. What do I do with this number and this number? Add them up because now they're connected in series. So our circuit is equal to 10.4 plus what? Which is 15. Guys. So now you know what? You know the voltage of the whole circuit and you know the resistance of the whole circuit. What can you calculate? The current of the whole circuit, which is really the current through the what? Or coming from the what? Coming from the battery. Perfect. So I bat equals 12 divided by 15.4, which is slightly less than 0.8. 0.779. 779 amps. Now can I do A? Yes, I can. I equals Q over delta T. So Q equals I delta T. Come on. 0.779 times how much time? 7 seconds. Equals zero point 0.8 times 7, 5.5 something. Haley, what'd you get? 5.453, so 45. In what? In coulombs. Nice. How would you do part B? Part B is asking how many coulombs will pass through which resistance? R2, which means I need now to calculate the what? The current just through R2. Just through R2. Can someone tell me how to do that? How do you just calculate the currents in parallel? Remember what we did yesterday for worksheet number 8. Everyone, how much is going this way? 0.779. 0.779 amps. So how much is going into the group? 0.779. Good. I know how much is going into the group, and I know what the group is. The group is 10.4. Everyone, the group is 10.4. So, sorry? 10.4, the group 10.4 ohms. So everyone, V right here, V equals current times 10.4. So 0.779 times 10.4, which is 0.779. Oops, sorry, 0.779 times 10.4. 8.10. So exactly. It's 8.10 across the whole thing, and across the top, and across the bottom. So that means it's 8.10 volts here. Now what can I do? I know the voltage, I know the resistance of the. I can find how many electron or how much charge is going through. So I2 from here, I2 is equal to what? 8.10 divided by 16. Haley, 0.5 what? Slightly more than half. Slightly more than half. 5? 5.1? Okay, 5.1 amps. And now what do? I do this thing again. I do this thing again. But for two different numbers, for an I of 0.51 and for a time of 12 seconds. So I'm just going to leave this up here. Do me a favor and really watch this video during this week and next week. This is a very good crash course into everything we've done for 4 days. You owe it to yourself to be ready for the test on next Monday, not this Monday, next Monday, to really watch this video and redo everything. Because many of you I know are feeling a bit hopeless. That's fine. This was a rough week, but at least I'm trying to watch crash course the whole thing and give you a full week to watch. Okay, next question. Yes, oh, it's recording right now. Oh, 100%. Like the video. I'll see what I can get through next week, but at least the video for sure. Okay, next. 56. Okay, listen up. I'm not gonna do 56. 56 is yours. Not now. It's very similar to the one we just did. Please make sure you give it some thought. It's exactly the same amount of work. Look, one resistor in series, two resistors in parallel. So please work at this at some point. Next. 58. Okay. This is a good question. Listen up. Everyone, pencils down. Read this. A student has how many resistors? 3. One is what? One is what? One is. How could they connect them to produce an overall resistance of 60? I have a question for you. Could they connect them all in series? 75, 50, and 30. Why can they not connect all of them in series? No, forget the amps. Just think of resistance. When you connect them in series, what's the full resistance? What do you just do with the numbers? You add them up. What when you add? You already have how much at the beginning? You already have more than what you want. So you cannot connect them in what? Can you connect all of them in parallel? Ali, why not? Listen up. Can you make a 3-stack, a pure 3-stack? Why not? Remember, when you connect in parallel, the result is lower than the least. What's the least we have? What's the one we want? Sorry, 60 is higher than 2 of them. So what should we do? Is it a pure or a mix? It has to be a what? A mix. The question is, what mix? What mix? Okay, well, let's see. Okay, question. What did I do? Sorry. You. For parallel, the REQ at the end, after you flip and do the stuff, is lower than the least. Lower than the smallest one. Smallest than the smallest. 1 second. Let me just. Okay, everyone. So we know it's gonna be like. Oops, sorry. Everyone, we know it's gonna be like this, right? Right? Could you put 50 here? Could you? Possibly, yes. Okay. Which means here is what? 30 and 75. Okay, go ahead and let's calculate. What's 1 over 30 plus 1 over what? I know at least it's going to be less than 30, right? Everyone, for those two, the outcome of just those two will be less than 30 for sure, because it's lower than the least in the stack. Okay, what's the common denominator for 75? Say again? 20. Okay, 21.4, which means what? Plus 50 will give me what? More than 60. So that's a bad combination. Okay, so what should we replace? Could I put 75 here? It's already bigger than 60. So if 50 doesn't work, what could work? 30. Okay, let's do 30. Everyone, let's do 30. Guys. 50 and 75 gives me a combination of how much? How much? 1 over 30. So the 30 plus the 30 will give me what? There you go. So again, imagine, listen up. Imagine if you didn't know listen, guys. Imagine if you didn't know that when you connect them in parallel, you produce lower than the least. What are you gonna do? You're gonna waste so much time trying what, right? Because you didn't know, and you got tried the 75, and you shouldn't have tried the 75. Is it making sense? So it's good to know the logical bounds of your answers. Good. All right. Next question. Similar idea. Okay. Oops. Guys, how many resistors now? How many? 4, 7, 12, 24, 28. I need to produce 13.6. Can I put 28? By the way, what possibly could I put 3 of them in series? Could I put 3 of them in series? No. No, I can't. Because any 3 of those you put in series will give you more than 13.6. Right? Everyone look. Yeah, I'm saying if you put 3 in series, how about if you, okay, can you put 2 of them in series? No, still bad. Because 7 plus 12, the least ones, is how much? Is bigger than 9. So that means what? You cannot have what? Exactly. Maybe you could put this one in series, which means what? How much of a stack are you going to have? 3. Do you see what I mean here? Okay. All right. What's my stack? My stack has got to be 12, 24, and 28. Okay. So let's do that. Let me make a quick sketch. New. Okay. 7. Yeah. 12, 24, 28. I need someone to do 1 over 12 plus 1 over 24 plus 1 over 28. 6 point plus 7, 13.2. Got it. Everyone, that's the only possibility. That's the only possibility. By the way, question, everyone. What's the lowest one in the stack? No, in the stack. 12, which means whatever we get for the stack has got to be less than 12. How much do you get? You get 6.2, right? 6.2 makes perfect sense. And that 6.2 represents what? Represents this whole thing. So 7 plus 6.2 is equal to what? Check. Please let this sink in. When you do a stack, you produce lower than the lowest. When you do a train, you do greater than the greatest. All right. Nope. Oh, remember we did those yesterday, right? Derive an expression for power in terms of I and V. P equals IV. We did that yesterday. Okay. 59, 62. Everyone, 62. Interesting. What do we have here? Do we have in parallel? Do we have an in parallel arrangement? Do we at least have an in parallel in front of us? But inside of it, there's what? Two in series on top, one in series on top, one in series at the bottom. Okay. What do we have? R1 is 30, R2 is 50, R3 and R4 are both what? Can we just combine both the top ones and bottom ones? Yeah, we can. Okay, let's do this one together. Come on. Snip, 1 second. You can start if you want. Well, you're not gonna see it for a bit because I'm gonna snip right now. All right. Okay. File new. Okay. All right. Let's put some numbers. This one is 30. 30 ohms. This one is 50 ohms. This one is 60 ohms. 60 ohms. Anything else? V1 is only what? Okay. Can someone tell me? Can someone tell me what to do? Okay. Wait. I'll give you a hint. No. Even before. Even before. What do I know about R1? Come on. What do I know about R1? I know the voltage and resistance. What can I calculate? Which is the same current through R2. Perfect. See, that's even before combining. So let's do that. So, everyone, what's 12 divided by 30? 0.4. Yes, 40%. Okay, everyone. So, right here is 0.4 amps, which means also here what? Interesting. Now I know what about R2? The volt. No. What do I know? Exactly. I know the amperage. I know the resistance. What can I find out? The voltage. But divide or multiply for volts. V equals I times R. So multiply. So now we're going to calculate what? 50 times 0.4. Just what? What? Okay, everyone. So what's the total voltage in the upper branch? In the upper branch. 12 plus what? 20. But what do they say about stacks? They have the same what? They have the same voltage, which means what? From here. Exactly. From here to here is what? Asser, can I now combine the two 60s? Yes, I can. What's 60 plus 60? And then you're going to divide 32 volts by what? By 120 ohms to see how much is stolen across the, through the bottom branch. That gives you the amperage right here, everyone, right here. You've already split, so adding them, you'll go back in time and know exactly how much to start with. Again, the tracing method. All right, so let's do that. What's 32 divided by 120? Haley, 32. Slightly more than 0.3. Sorry, slightly more than 0.25. How much? So here, 0.26 amps. Great. So that means right here is what is the zero point 0.4 amps plus 0.26 amps. Everyone, just so you know, listen up, pencils down. This way I'm showing you of quickly doing so much in your head is actually what they expect you to do when you do circuit problems for small circuits in university. They actually expect you to do a lot on the diagram immediately without showing so much work because you're going to be wasting so much time if you do so. Seriously, this tracing idea, visualization of the tracing is really powerful. You can see how quick I am. You need to actually know that this is a skill that's needed for next year, or sorry, in 2 years. So what's the 0.4 plus 26? 0.666. 0.66 amps. So what's V source? No, yeah. I'll give you a hint, everyone. How much is the voltage across this part? 32. How about here? How about from here to here? Is there anything else in the circuit? Which means what? It's 32 volts. Basically, everyone, look. Can you replace all this? Can you replace all this with a single resistance? Yes, you can. That resistance is going to have 32 volts across of it. That resistance, which we can calculate right now by one parallel or whatever, 1 over IQ, this will be 32 volts. That's it. You really just have one resistance in this problem if you squish everything. All right.